I started working in a switchgear manufacturing company, and when I first saw the control schematic of the high voltage circuit breaker, I felt like somebody drew a puzzle on the paper or maybe a maze on the puzzle. I was so confused. I felt it is so complex, and I thought I would never understand this in my life. But then I realized if we look at this drawing in a systematic way, in a stepwise manner, if we understand, then that puzzle starts solving. That puzzle starts unfolding. And the complete drawings then becomes the logical way of understanding things. Now, I've used 5 simple steps to understand complex circuits in the electrical industry. And in fact, I've used those 5 steps to create a dedicated course on circuit breaker control schematics, which has helped more than 600 students all across the globe. And in this video, I'm going to share you those 5 simple steps which you can use to get start your understanding on the electrical schematics. Now, before we jump into the 5 simple step, it is equally important for you to understand what do we mean by electrical schematics. So let's understand that with a simple example. Imagine I send you in a maze with no map, or maybe a jungle with no map and nothing. Now you will go inside and you will roam around, but you will not find where are the different paths, where are the junctions, what's the destination. You would have no idea, right? But next time I send you in that same jungle, but with a map now. Now that map shows you where are the different paths, what are the different junctions you have, what is the destination. Now, once you have that in hand, everything becomes easy. The navigation into the jungle becomes so easy, right? So, in the electrical industry, the electrical schematic is basically that map you have. If you open the control circuitries of any of the electrical devices of the switchgears, you will find the jungle of wirings, right? And you would have no idea what are you looking at if you don't have the electrical schematics. So the electrical schematics becomes a simple map for you to understand how the connections are made, what are the different junctions we have, and how the equipments are connected, what are the electrical interlocks are provided. So everything is given into that electrical schematics. So that's the electrical schematics. Now, electrical schematics can be used in multiple ways. The electrical schematics can be used in medium and low voltage switchgears. Not can be, it is used in the medium and low voltage switchgear to represent all the logics and everything. It is used in ringman units. It is used in high and extra high voltage circuit breaker as well. Now these are just simple examples. Okay, this it's not limited to this. The application is very wide in the industrial automations. The PLC logics and everything can also be shown, and it is shown using the electrical schematics. So the application is very wide, and some or the other day you'll have to look at that drawing. And if you feel like it's a puzzle, well, don't worry, because I'm going to give you those 5 simple steps which you can use to understand or find out your path from that jungle. So let's start with the step number 1. The step number 1 is understand the components. Now this is the step that you have to take even before you go and pick up the electrical schematic. This is the very initial stage. What you have to do is, in this stage, you have to understand the different component we use inside the control circuitry of any device, right? So for example, we use contactor, we use relay, fuse, push buttons, remote, and local selector switch, and there are n number of secondary components that we use. The first thing is you need to understand the function of each and every component, why we use it and what they do. This is super crucial. For example, we have contactor. Now contactors are very commonly used in building the electrical logics. And if you don't know how this contactor operate, what are its constructional feature, how it looks, it will be very difficult for you to understand the electrical logics and how they operate. So the first thing is you have to understand the different components that we use inside the control circuitry. Once you have that understanding, then the next steps really become very, very easy for you, which takes us to the second step, in which we have to get familiar with the different symbols and the basic structure of the electrical schematics. Now, before we continue, I would like to thank Cofaso for sponsoring this video. Cofaso is an electrical CAD software designed for electrical engineering, automation, and control panel projects. Apart from creating electrical schematics, it can automatically generate important project documentation such as terminal plans, cable and wiring list, device list, and even the bill of materials, helping engineers reduce a lot of repetitive documentation work. Another useful feature is its component library. Cofaso provides micro libraries for the component manufacturer, but Cofaso users can also import manufacturers' micro libraries directly into Cofaso by themselves. This makes it easier to work with actual component while developing your electrical designs and other things. Now, if you're interested in exploring Cofaso, you can find the link of the software in the description below. Definitely check that out. Now, when you open the electrical schematics or you take the paper on in your hand, you will find there are different sections. One of the important section which you will find at the bottom is the title block. First thing is you have to understand what this drawing is about. Is it a closing circuit? Is it a tripping circuit? Is it a PLC wiring? Is it auxiliary circuit? What it is, you have to understand that. The title block will give you that understanding. It will tell you the customer name, the project name, and the different things that are mentioned there. So first, understand the title block of the drawing, which you will very easily find at the bottom of the drawing. Now, once you understand what this drawing is about, the next thing you have to understand that what are the different symbols we use for the different components. We do not represent a contactor with a contactor image in the drawings, right? We represent it using a standard symbol. And if you show the actual image of the component, then it becomes very complex because you cannot fit everything in one paper basically. And the look of the components may change manufacturer to manufacturer, and then it will become really confusing what this device is. So instead of that, what we do is we use a standard symbol to represent the different component. For example, for the contactor, we use the symbol that you see on the screen. Now, there are different standard international standards we have, which gives the list of standard symbol that needs to be used in the electrical schematics. So it will change based on what standard your country follows, and it will also vary slightly based on what software you use to draw the schematic. So please take a note of this. It may vary, so you have to first see what are the different symbols. Now, where can you see this symbol? So if you have the complete set of drawing, you can see in front or at the bottom you will find the abbreviations or the bill of material, where the manufacturer or the designer shows the different symbols that we have used for the different components. So that's the second step. You have to go through that bill of material, understand what are the different symbols represents the different component. This is very crucial. If you miss out on this, believe me, when you go inside the drawing, you will not have any clue what this component is and why it is there. So understanding those symbols are really important. Now, once you understand the symbol, you have to also understand what designations we are using for that symbol. Because in the drawing, I will not write, okay, this is contactor 1, this is relay 1, or this is a fuse. No, it will be written using some standard designations. So for example, for contactor, I can write K1. Second contactor, I can write K2. So those things where you will get again in the abbreviations or the bill of material table that is provided. Understand those designations. You will also see, like for example, for contactor, most commonly you will find A1 and A2 is written. This indicates it's the coil of the contactor, and this is where you have to connect the supply, right? And this is where the step number 1 becomes very important. Now, if you don't know what is the coil inside the contactor, how would you understand the drawing? How would you understand what is A1 and A2? So that's why the step 1 becomes really, really important. Don't ignore that. And most people makes a mistake there. They will not understand the basics. They will straight away jump into the drawings. That will never help, believe me. So that is our second step. Get familiar with the symbol, understand the title block, and understand the different designation that we use. which takes us to the step number 3, where we have to understand the different assumptions made by the manufacturer while designing the drawing or by the designer. Now, when the drawings are made, definitely there are certain assumptions that we make. Now, for example, what are these assumptions? Let me give you a quick example. Imagine we have this contactor here, which is represented by K1, and then there is a contact of the contactor. Now, contactor will have different contacts, normally open, normally closed contact. If you look at this particular drawing, it is difficult for you to understand whether the current position that we see right now, is it the default position of the contactor or is it the energized position? Because as we know, when the contactor is energized, the contacts of the contactor will change their positions. Now, by looking at the drawing, you won't understand what is the stage of the contactor. Is it energized or is it not? And that's where the assumptions made by the designer becomes very important. So designer will write all the contactors are shown are in de-energized condition. That's the assumption. That means this particular position of this contact is by default position, which is normally open, an O contact, right? And the moment this contactor is energized, this contact will close and the position will be changed, right? So this is something very important and you need to understand this. Same thing can happen for the opposite contact, where the contact is normally closed, and that's the default condition of the contact. If the contactor is energized, the contact will open, right? That becomes the open position. So that's one assumption. Second assumption, for example, if this is a circuit breaker drawing, then whether the circuit breaker is in the closed condition or open condition, that needs to be assumed while drawing the diagram, and accordingly you have to show the contacts. So all those assumptions you have to understand. Again, where you will find it, when you look at the drawing, you will find those assumptions mentioned on top of the few pages or maybe at the few last pages. So first look at those assumptions and then you will have clear idea, okay, why this contact is in open condition, why this is in closed condition. So that is step number 3, which then takes us to step number 4, where we have to understand the schematic structure and the power flow. Now, when you see the electrical schematic or wiring diagram, you will see it doesn't start directly with the schematics or with the wiring. There will be initial pages, there will be a title block, project details, which talks about what project it is, who is the customer, the project things and that. And then every page will have a dedicated circuit. So because you cannot fit all the circuits into one single page, so there will be segregations of that. So you have to understand on that particular page what circuit is shown. For example, one page may show, in case of RMU, the wirings of the load break switch. The second page may show wiring of the circuit breaker. So it's divided. So you have to understand the structure of that. The schematics or the wiring diagram can show a regular 3-phase supply in the low voltage application, including neutral and protective earth. So in that case, you have to identify where the power source is. And from the power source, then you follow the path, right? That's the standard practice. The electrical schematics can also represent the DC supply. In that case, in most of the European practice, you will find the positive line is on the top and the negative line is at the bottom. And in between, they will draw the different circuits. And the thumb rule is the circuits will be drawn from top to bottom and not from bottom to top. So when you are reading, you have to start, if it's a DC representation, you have to start from the top to bottom, right? And if it's a AC supply, you have to identify the power source and then follow the power source, which is generally from left to right. So that's how you have to understand how the structure of the schematics is and how the power flow is there. Which takes us to the next step, which is understanding the power flow continuation. Now, this is where I used to get a lot of confusion, but then I realized there is a method to, understand the power structure. So you can see here is one example. This is drawn on the Cofaso software. You can see we have the power supply here. The diagram or the wiring is flowing from left to the right. Now, certainly on a single page, I cannot show everything, right? So I have to use multiple pages. So the power flow will flow from one page to another page. And there are also a method to understand that. So if I go to the next page of this, you will find here on the left hand side some numberings are mentioned, which is 3.10. So 3.10 represent that this is the incoming supply from page number 3, which was the previous page, because this is page number 4. So it is coming from page number 3 and from column number 10. So you see on top, we have 10 columns, 1, 2 till 10. These are columns. And this is important because if you have used Excel, this is similar to that of Excel. The only thing is we don't have specific row numbers, but we have the column number. And when I say 3.10, that means it's coming from the page number 3 and column number 10. So if I go back, you see this is the column number 10. So from here, it is getting continued to the page number 4 and this particular section. I used to get a lot of confused here because I wouldn't understand where the supply is coming on this page. Okay, from on page 1, I understand it, there is a dedicated supply, but from where it is coming. So it basically was coming from the previous bus bar, and this also shows this is the continuation of the bus bar only. So this is very important. You understand how the power flow is continued to the different pages. This will help you understand the drawings. Now, if you use this 5 simple step, everything becomes easy. The puzzle starts to unfold, right? So I hope those 5 steps will definitely help you. But the question is, will these 5 steps enough to help you understand the complete drawing? Certainly not. This is the starting point. Okay, this is how you start. This is how you follow the drawings. Unless and until you practice, nothing is going to work out. So this 5 steps acts as a starting point for you. So I hope this was helpful. And if you're interested in learning and understanding about circuit breaker control schematics, I have a dedicated course on that. You will find a link for it down in the description. I hope those 5 steps was helpful. And if this type of content is helping you, do comment wiring in the comment section below. That way I'll understand this type of content is reaching the right people and also helping you. Thank you so much for watching, guys, and thank you for Kofaso for sponsoring this video. If you're interested in learning more about them, you'll find their link down in the description. Thank you for watching, guys. I'll see you in the next one. Till then, keep watching, keep learning.